Hello, this is going to be the second polynomial, a cubic polynomial, where we are looking to factor this and to figure out the roots of this polynomial in order to generate a sketch. One of the things is that you can go ahead and generate your P over Q list, which is going to be a ratio of, again, plus or minus 1 and plus or minus 7. But one of the unique things to notice here about structure is that I happen to realize that I can factor this by grouping. If you don't realize this, you can go ahead and do the problem the same way that we were doing the last couple problems. But I happen to see that when I'm looking at this, again, Q2, this is Q sub 2 equation, and problem 108, that I could factor out an x squared from this first group. And also I could factor out a -7 from the second group, and what would be remaining would be the same, so it was factorable. So if I do that, I get x squared times x plus 1. And if I take out the 7 that is common to both of the next two terms, I would have the x plus 1. So this is this unique case where you can actually factor by grouping. And so here I can simplify this, as this is going to be the same thing as grabbing that x squared and grabbing that -7, putting them together to be x squared minus 7, and then times the x plus 1. So I just factored that in an alternative way, and I was able to figure out the roots just looking at this factored form. So if this is again your q sub 2 of x in factored form, and we are looking to find the roots are when the output is 0. So if you're using the concept of zero product property, it's either when x squared minus 7 equals 0 or x plus 1 equals 0. And so the value here was clearly -1. You could probably see that through inspection. And here when I move the 7 to the other side and then take the square root, don't forget we would have the absolute value of x coming out here equaling, in this case, the square root of 7. And so really we've got plus or minus the square root of 7, which is, by the way, a little bit smaller than 3. Bigger than 2, because again the square root of 9 is going to be 3, and this is only the square root of 7, so it's not quite 3, but it's bigger than 2. So I can use these to actually plot these points of the -1 on my graph. And then again, we were saying that it was the square root of 7 and plus or minus. So again, it was in between 2 and 3 on the positive and the negative side. This is a cubic. It will look something like this, where it will start and end in this opposite directions because it's an odd degree polynomial. I know by looking at the constant that this, in this case, has a y-intercept at 0, -7. And that again helps me to think about, well, how do I generate this curve? So I just sketch this curve, and then it passes on through. And again, this is just a very rough sketch, but clearly represents the x-intercepts and the y-intercept.